Okay, guys, so we are on section 8.1, and it is confidence intervals for a population mean. Standard deviation, no. The first whole page here that we have, and I will, of course, post these in Canvas, is we talk about some definitions. So a parameter is a numerical summary of a population, such as a population mean mu or a population proportion p. A point estimate is a single number that is used to estimate the value of an unknown parameter. The margin of error is how close something is to the population mean, plus or minus. Standard deviation equals the standard error of the mean, and that's going to be sigma divided by the square root of n. This becomes very important. Margin of error also is very important. You do have some homework questions over point estimate. Approximately 95% of data will have z-scores between -2 and 2. I added that in there. That was back from where we talked about a normal distribution and then the empirical rule. Okay, the z-score, the positive one that correlates to the confidence interval, is known as a critical value. This becomes very important. Also, we're going to calculate some of those. We'll use the critical value and standard error to calculate the margin of error. This becomes very important. We've got to have the margin of error equals the critical value times the standard deviation. And like I said, in the next few example problems, we calculate that quite often. A confidence interval is an interval that is used to estimate the value of a parameter. The confidence level is a percentage between 0 and 100% that measures the success rate of the method used to construct a confidence interval. If we were to draw many samples and use one to construct a confidence interval, then in the long run, the percentage of confidence intervals that cover the true value would be equal to the confidence level. Confidence levels, it may be any percentage between 0 and 100. However, in practice, we generally use 90, 95, 99 because we want to have a high confidence level. You'll need to remember from previous sections that inverse norm in your calculator is used to find the z-score that correlates to a certain area, and normal CDF is used to find the area given the z-score. Okay, those are real important today. Those are the two functions that we use on our calculator. You need one more little definition before we get started there. It says, let alpha be any number between 0 and 1. In other words, alpha is between 0 and 1. 0 is less than alpha is less than 1. The notation z alpha refers to the z-score with an area of alpha to its right. The notation of alpha over 2 refers to the z-score with an area of alpha over 2 to its right. And that's a little vague and a little vocabulary wordy there, but we will work on that in the next few examples, okay? Okay, so let's look at number 1. Number 1 says, find the critical value, z sub alpha over 2, to construct a confidence interval with level A 90%. So let's talk about what this looks like. And guys, all this works better if we have a picture. So we're talking about our normal curve. Okay, and what this is saying is we have a 90% confidence level. So this is 90%. Guys, the alpha is what's left. Okay, well, if I reach 100% and I'm at a 90% confidence level, my alpha then is 10%, and that makes alpha over 2 equal to 5%. Guys, we divide it by 2 because we're talking about the two tails. So this becomes 5%, and this becomes 5%, okay? We want to find the critical value, and the way this value right here is going to be my critical value. Okay, and we're going to find that using the inverse norm. All right, so if I have inverse norm of, and I do need to pull that up on your, okay, on your, I need to pull that up here on the iPad. Okay, so what I'm going to get is, guys, you got to know what to put in the inverse norm. Okay, it's not going to be 90%. That chunk in the middle is 90%. So when we use our inverse norm function, if we're looking for this critical value right here, what are we talking about? We're talking about the 5% up through that chunk of 90%. So I'm actually going to go over here to our calculator, and I'm going to use my second vars. I'm going to go to inverse norm, okay, and my area is 95, so 0.95. We're still talking about a standard curve, so 0 and 1 for mu and standard deviation sigma, and we're talking to the left. Okay, now yours is going to look a little different. Yours won't have the left on there more than likely. It's going to have just inverse norm 0.9501, and that will give you the 1.645. So you will have 0.95, comma 0, comma 1, and that is going to give me 1.6449 about. Okay. On B, we have 98%. Let's look at what it's talking about. Okay, so my confidence interval here is 98%. Okay. Well, that means my alpha is, there's 2% left, guys. So alpha over 2 is going to be 1%, because how much is up here? Well, there's got to be 1 at the beginning and 1% at the end. Well, that means when I find that inverse norm, I'm really looking at 0.99, right? Because I've got my 1% and my 98%, 0, comma 1. It's still going to tell to the left. You actually probably could, if your calculator asks you about left and right and center. Let me work it this way real quick. I don't know why I have a negative there. What do we have? 9, 9? Yeah. And we're going to the left. I need to take that negative value out. I do get 2.3263. You probably could, if your calculator is asking you left and right. We're going to try it out right here and see what happens. If I go right here and I tell it, if I do second vars and I'm doing inverse norm, and if I start with just what they gave me, that 98% that's in the middle, so I say 0.98, and then I do a 0, 1, and this time I say that 98% is in the center, we should get the same answer, and we do. Oh, that's nice. It gives us both values. When we do the center, I might suggest upgrading your operating system if yours doesn't do left, right, or center. I know Robert's does. So he can say center and get that right value, which is the critical value there. I will continue to work on without the left, right, center. Okay. 99.5%. All right. So I've got this is 99 0.5%. So let's think about it. Alpha then means that is 0.5% away from 100%. So what will each of my halves be? Okay, that means divide that by 2. That's, and this is not, yeah, it is 0.5. That's going to be 0.25%. Remember, those are percents there. So I'm going to do an inverse norm of, let's see, this also has 0.25, so that's going to be 0.9975. And I'm going from 0 to 1, and I'm going to pick left. I'm not going to write left on there because most of you guys don't have the left. So if I go back over here, and I'm typing in, I'm going to go back up to this one, and I'm going to insert. I want 997501 left, and that's going to give me 2.8070. Okay. And then if I'm looking at 80%, so my confidence interval is 80%. Well, if that's 80%, that means my alpha that's left is 20%. So alpha over 2 is 10%. Okay. So this is 10%. This is 10%. So I go back in my inverse norm, then I'm going to be at 90%. I'm just going to zero those out, and that should give me 1.2816. So I have inverse norm. I'm getting 0.90,01 equals 1.2816. I must say that is a nice feature. If you do have the left, right, center, you are welcome to just do the center at what the confidence interval is that they tell you. Such as here, oh, it was 80. Okay, I should get the same thing, and sure enough, I do. Okay, so let's look at number 2. 2 says find the levels of the confidence intervals that have the following critical values. Okay, so this means we're pretty much looking for the percent this time. So this time we're going to use normal CDF. That's why I gave you that little reminder. Okay. So what I have here this time is I know this critical value right here is 1.96. Okay. So I'm going to find the area that's covered from 1.96 to the left. So I'm going to normal CDF this, and it should be, I'm going from the left up to 1.96. So I've got -1 e to the 99, 1.96, comma 0, comma 1. Okay, so this is going to give me, if I go over here to second vars, and I'm going to normal CDF. We actually probably could normal PDF if we wanted that exact value right there. We'll try it and see what it says. The upper was at 1.96. Okay, and everything else stays the same. And I get 0.975. Okay, so that's 0.975. That's not your answer, guys. What this means is all this chunk right here is 97.5%. This whole big chunk right here. That means this little chunk is what? I'm going to say 100% minus the 97.5%, and that's going to give me 2.5%. Okay, well, if that little chunk is 2.5%, then that means I need to chop this part over here, and this chunk has to be 2.5%, which then makes this, well, we're going to say 100 minus 2.5% times 2, and that will give me 95% is my confidence interval. Okay, so I get a confidence interval of 95%. Let's see if that, I do think normal PDF there will work. We had it for 1.96. Oops, sorry guys. So if I do a second vars, remember normal PDF is stagnant. It's right at one spot. Let's see what it says. It may not. Was it 1.96? Okay. Nope. Yes, it does. Look, 0.05. Okay. And that's like, no, it doesn't. That doesn't work out well. Okay. Because that was about 5% off. You need to do it with the normal CDF. Okay. So that takes care of 2 with 95%. Okay, so now I have a z-score of sub alpha over 2 equals 2.71. Okay, so what I have right here is I'm going, okay, well, this is 2.17, not 71, 17. Okay, so I'm going to go over here. I'm going to do a normal CDF. And I'm going to go from negative 1E99 all the way up to 2.17. And that's still 0. That's still 1 because we're looking at a normal. I'm going to go back up here to my normal CDF. Okay. And we're going to put in, what did we say? It was 2.17. Okay. That's going to give me 0.9849. That's 0.9849. Remember, that's not the answer. This right here is about 98% is what we're looking at. Okay. So that means this chunk is 2%, right? Okay. So that means, let's not round that far. Let's leave this at, let's round it. Let's not round it up that much. Let's leave it at 0.985. Okay. So if this is 0.985%, so 98.5%, then that means if I say the 100 minus 98.5, that's going to give me 100 minus 98.5 is 1.5. Okay, so that is 1.5%. Well, if that little chunk is 1.5%, then this means this chunk down here has to be 1.5%. Added together, they make 3%. So this is a 97% confidence interval right here. Okay. Yeah, and that was actually what we wanted. Okay. right, then let's look at C. We have the z-score of sub alpha over 2 equals 1.28. Once again, here's what I've got. This is 1.28 right here. Okay, so let's do a normal CDF. Let's find out what all this big chunk right here is. Okay, so I've got negative 1e99 all the way up to 1.28, 0, 1. I'm going to go back up here. I'm going to do a normal CDF. Okay, and I'm going to do, let's see, upper is 1.28. And I get 0.8997. Are we liking that pretty good? What am I on? C. And that one is going to round, if I start rounding it, it is going to round up to approximately 0.90. So if this is 0.90, all this chunk down here, that means this is 10%, because this is 90%. That's what 0.90 is. Okay, but we also know that if that is 10% at the top, then I've got to show a 10% down here to the left on the bottom. And that's going to change that to an 80% confidence interval. Okay. Good job. All right. Oh, we do have a D. See what D says. D says I've got Z sub alpha over 2 is 3.28. So once again, look at your picture, guys. It does help if you draw a picture. This is 3.28. Okay, as it's going to be pretty high, because think about it. This is a mean of 0 and a standard deviation of 1. And if we're talking about a standard deviation of a z-score of 3.28, that's 3 standard deviations away. We use the empirical rule. That means that's that's almost all, okay? So you should have nearly up to 100% here. We're going to do a normal CDF. And that's negative 1 e to the 99. And we're going up to a 3.28. Mean of 0, standard deviation of 1. When we plug that in, that is going to give me 0.99948. So what this says is this is 99.9% of the population there. All I'm missing is 0.1%. Okay, so if that's 0.1%, then that means that over here I have 0.1%, which means that I have 99.8% there. Okay, so I get 99.8%. Okay. And actually, if I'm using 99.9, that's going to be, look there, guys. Hold on. Look, I didn't give it enough. Look, if I'm getting, this is 99.9%. So if I say 100 minus 99.9, what do I get? That's going to give me 0.1. Now, oh, that's what I got. We're good. That little chunk is 0.1. right? This is 0.1. We're okay. I got it good. So that means that's percent, 0.1%. This one is 0.1%, okay? So then we say 100 minus 0.1 times 2, okay? And 100 minus 0.1 times 2 is going to give me 99.8. Yep. Okay. We were all right with that. Okay. Number 3. Number 3 says, find the margin of error given the standard error and the confidence level. I remember the formula that we just wrote for margin of error. Margin of error equals the critical value times the standard of error. Okay, so I'm just going to call it ME. My margin of error here is going to be, let's see, we have a confidence level, but in order to find that margin of error there, what do I need first? I got to find a critical value. Okay, so here's what I have. My confidence level, this chunk in the middle, is 95%. Okay, that means there's 5% missing. That means this is 2.5%, and this is 2.5%. That means this whole thing right here is 97.5%. Okay, so I'm going to do an inverse norm of 0.97501. And when I do that, let's go over here. If I do, how far away is my inverse norm? Oh, I don't want to do a center. So I'm going to do a second bars. I'll just do a new one. Inverse norm. And I am doing 0.975. Yes. 0 and 1, we're going to left. We're going to tell to the left, and we're going to paste. And that's going to give me 1.95996. 1.95996. So 1.96 is my critical value right here. This one is 1.96 approximately. Okay, so my margin of error is going to equal 1.96 times 1.2, and that should give me around, 2.352. Okay. Okay, let's look at B. I have a standard error of 0.4, confidence level of 99%. Okay, so if my confidence level is 99%, here's my 99%. Okay, that means there's 1%. 1% divided by 2 is 0.5%. So this is 0.5%. This is 0.5%. So that means to find that critical value, that's going to equal my inverse norm of 99.5%, so 0.995, comma 0, comma 1. Okay, so let's go back over here. Let's do an inverse norm. 9501 left, 2.57, Yes, 58. Yep. That gives me 2.5758. Now I'm ready to find that margin of error, and that's going to be my critical value, 2.5758 times that standard error, which is 0.4. 2.5758 times 0.4 is going to give me 1.0303. Okay, for my margin of error. Okay, guys, things going to work pretty much the same on C and D there. Okay, I'll go ahead and work C and D so we can practice a little bit and you can practice with me. So I've got a standard error of 3.5. I've got a confidence level of 90%. So I need to find that critical value. I know that'll be an inverse norm. Just got to figure out of what. And I have confidence level of 90%. So if this is 90%, that means this is 5% and this is 5%. So that's going to be of 95, so 0.9501. When I put that in the calculator, I should get 1.64485, hopefully. Let's go back over here. And I'm looking for 95. Let's just make that a 5 and a 0. And I do get 1.64485. So now I'm going to find that margin of error, and that is going to be 1.64 about. We'll say 4485. I got a little decimal happy, didn't I? And I'm going to multiply that times the standard error, which is 3.5. And when I do that, I should get 5.757. Okay, let's look at D. And then we'll get into some problems where we put all this together. Okay. All right, on D, I've got a standard error of 2.75 and a confidence level of 98%. Like I said, guys, draw your picture. This is 98%. So that means this is 1%. And this is 1%. When I go to find that critical value, and I do that inverse norm, I've got 0.99, and that's 0 to 1. Okay, so when I take the inverse norm of that, whoops, I've got 0.99. Correct, is that what I said? I think so. And that does give me 2.3263. Okay, that's my critical value. So now I can find my margin of error, which is going to be my critical value, 2.3263 times the standard error, which is 2.75. And that should give me 6.3975. Let's make sure. Let's just say times 2.75. Whoops. 2.75. And I get 6.3975. Yep. Okay. And that is my margin of error. I didn't box those on C and D. Okay, so let's look over here at example 4 and 5. An IQ test was given to a simple random sample of 75 students at a certain college. So that does tell me that N is 75 right there. The sample mean score was 105.2, so I've got a mean of 105.2. I think we were calling that X bar because that's a sample mean. Scores on this test are known to have a standard deviation of 10. Sigma equals 10. It is desired to construct a 90% confidence interval for the mean IQ score of this college. Okay, and we've got a 90% confidence interval. All right, what is the point estimate? Guys, the point estimate's just the mean. That will be 105.2. Okay, we need to find the critical value. So we want a 90% confidence interval. We want this to be 90, we want that to be 90%. That means I got to have 5 over here, and I got to have 5 to the left. So that means my critical value is going to equal the inverse norm of 0.95, comma, 0, comma 1. That should give me 1.6449. So I go over here and make sure. And I am putting in inverse norm. And I've got 0.95. Everybody else stays the same. And I do get 1.6449. Okay. Then I need to find my standard error. Well, my standard error is going to be sigma over the square root of n. Okay, that's going to give me 10. There's my critical value. That's going to give me 10 over the square root of 75. Okay, and that's going to give me, should give me 1.1547. If I have 10 divided by the square root of 75. Yep. Okay. Now I'm ready to find the margin of error. I think I'm hungry, guys. That's going to be my critical value times my standard error. Okay, my critical value is 1.6449, and we're going to multiply that times 1.1547, and that will give me 1.8994. Now we need to construct the 90% confidence interval. Okay, so what that means is you take that average, that mean, the 105.2, and you tell me what that, using your margin of error, what that lower bound and that upper bound is, okay? And that determines that 90% confidence interval. You've got to find those bound points. Well, you take the margin of error and you add and subtract from 105.2. So to find the lower, I'm going to say 105.2 minus 1.8994, which that will give me 103.3. Okay, and that means that mu is greater than 103.3, and it is less than, now calculate that upper, I'm going to take that 105.2 plus 1.8994. So 105.2 plus 1.8994, and that gives me 107.1. Let me scoot this up just a little bit right there. Okay, hold on. Let me scoot this. He's not wanting to cooperate. It's not going to move. It's going to move the whole thing, of course. Okay, and we get 107. Okay, yeah, let's see. Where did we go? I'm not redoing all that. That's going to give me 107.1. So my 90% confidence interval is from 103.3 is less than mu is less than 107.1. Okay. Now, F says, is it likely that the population mean mu is greater than 100? Yes, because we can say that with 90% confidence, that mean is going to be between 103 and 107. So it is likely that it's going to be over 100. So we say yes, because we are 90% confident that 103.3 is less than mu is less than 107.1. All right, 5. 5 says, let's see. 5 says the lifetime of a certain type of battery is known to be normally distributed with standard deviation of sigma equals 20 hours. A sample of 50 batteries had a mean lifetime of 120.1 hours. So I got okay, me and the photos here. I'm about done with that. And I'm even using my iPad, guys. 120.1 hours. A standard deviation was 20 hours. Okay. Had a sample in, now guys, that's the standard deviation of the population. It's not the random sample. Okay. That's what you're finding when you find the standard error. We're finding the standard deviation of that sample size there, that proportion. Okay. A sample of 50 batteries, N equals 50, had a mean life of 121 hours. We got that. It is desired to construct a 95% confidence interval for the mean lifetime for this type of battery. So confidence interval equals 95%. Okay. All right. So let's look. What is the point estimate? That one's pretty easy. 120.1. Okay. Find the critical value. Critical value is going to, we've got to take our confidence interval. We got to go, okay, this is 95%. That means those together have to be 5. So if that's 2.5%, then this has to be 2.5%. Okay. Now, so that means I'm doing an inverse norm of, that means I'm going to do an inverse norm of 97.5%. So my critical value will equal my inverse norm of, is this 4? What happened on 4? Something happened. Oh, I was at a 90% was it 90? Oh, I'm on number 5. Oh, sorry guys. It's been a long day. 95. So that's going to give me, my inverse norm is, yes, 0.975. And that is 0. That is 1. Okay. When I find that, I should be getting 1.96 when I put that in the calculator. So let's see if I go up here and I do an inverse norm of 0.97, insert 5. and that's 1.96. Yeah. Okay, now we need to find the standard error. Well, that's going to be the standard deviation over the square root of n. So that's going to give me 20. Let me box that. 20 over the square root of 50. And 20 over the square root of 50 is approximately 2.8284. You guys can put that in a calculator. Now we're ready to calculate that margin of error. So I'm going to take my critical value and I'm going to multiply that times my standard error, which is going to be 1.96 times 2.8284, which will give me 5.5437. Okay, now remember when we go to construct that confidence interval, okay, what was that mean? That was 120.1. So that means for my lower, I need to say 120.1 minus 5.5437. And for my upper, I'll need to say 120.1 plus 5.5437. Okay, and that will give me 114.5563 on that lower is less than mu is less than 125.6437. Okay, and then it says, is it likely that the population mean mu is greater than 130? No, it is not. No, we can say with 95% confidence that mu will be between 114.56 and 125.64. Okay. And let's see what number 6 brings us. We do need to do, guys, 7 and 8 are pretty much what we were doing. We're not going to do 7 and 8. We'll do 6. 7 and 8 uses example 4 and 5. I will tell you the answers on 7 and 8, and this should say use the data in exercise 4 to construct a 95% confidence interval for the mean IQ score. And you should be getting on 7, we should have 102.95 is less than mu is less than 107.454. And 8, that one is exercise 8, and it talks about the batteries again. And you should get, if you want to try those yourself, you should be getting 113.52 is less than mu is less than 126.68. Okay. Let's see what 6 says. I'm thinking, oh, we're doing true and false. Okay, so it says in a survey of a simple random sample of students at a certain college, the sample mean times per week spent watching television was 18.3 hours, and the margin of error for a 95% confidence interval is 1.2 hours. True or false? A 95% confidence interval for the mean number of hours per week spent watching television by students at this college is 17.1 is less than mu is less than 19.5. So we need to calculate those lower and upper bounds there. Okay, so the average was 18.3. So let's see what 18.3 minus that margin of error is, which we said was what? 1.2. So 18.3 minus 1.2 is 17.1. Okay, the lower checks out. Let's do the upper. 18.3 plus 1.2. It's going to be 19.5. So the upper checks out. So that is true. Okay, B says approximately 95% of the students at this university watch between 17.1 and 19.5 hours of television. That's what you would think, but no. 95% is the confidence level, so this is false. Confidence level is not the same as the area, guys. Okay, so that is false. I've told you answers for 7 and 8 if you want to calculate those. Number 9, I just need to make sure that you can read the data that's there. Okay, 9 says to estimate the accuracy of a laboratory scale, a weight known to have a mass of 100 grams is weighed 32 times. The reading of the scale is recorded each time. The following mini-tab output presents a 95% confidence interval for the mean regarding of the scale. Mean reading, not recording. I'm tired, guys. I'm glad we're nearly done. A scientist claims that the mean reading mu is actually 100 grams. Is it likely that this claim is true? So what I'm going to do is I need to look. We have a 95% confidence interval. Do I have a margin of error? Did it give me a margin of error? So let's look. We have 95%. Oh, we have one right there. It shows us that, okay? So score reading, we've got N is 32, a mean is 102, standard deviation is 2.5. Then we have, let's see, what else do we have there? And then we have, if we look, standard error is 0.44194, okay? And did we have, then we have our confidence interval. Look, it tells you your confidence interval, guys. 95% confidence interval, and that's going to go from 101 to 103. And it says that the mean reading is actually 100 grams. That is not true. Is it likely this claim is true? So that is no. Because we have a 95% confidence interval of 101.49, pretty much is less than mu is less than 103.22. Okay. Number 10, using the output in exercise 9, find the critical value for 99% confidence interval. Okay. So if this is, because this confidence interval was 95, if this is 99% confidence interval, then that means the remaining part is 1%, so this is 0.5%. 0.5%, okay? So I'm doing an inverse norm of 0.995. That's 0 to 1. And that should give me 2.5758. That's this value right here. Okay, and it says use the critical value along with the information in the output to construct a 99% confidence interval. Okay, so I know that the standard error is 0.44194, so I can find the margin of error on that 99% confidence interval to be that critical value times the standard error, which is going to give me 2.5758 times that standard error, which is, we saw that up there, 0.44194. That's going to give me 1.1382 for a margin of error. So now I need to take 102.3527. I need to subtract that 1.1382. And then I need to take that 102.3527 and I need to add that 1.1382. And that top one, we should have a lower bound of 101.2145 and we should have an upper bound of 103.4909. And that will give me 101.2145 is less than mu is less than 103.4909. All right, guys, and that sums up 8.1.